All right, guys, welcome back to chemistry. Today we are taking a look at a topic called density. We are basically trying to determine what density is and really understand what that concept means to us. So to start the class, I went ahead and I set several different items out on the lab bench here. So just to kind of go over what these items are, I have a bowling ball. Right, so I got a nice, and it's sitting in on a little dish here, so it doesn't roll away. But it's a pretty heavy, solid bowling ball here. Next to that, I have a piece of aluminum rod. Okay, so it's aluminum, just like the can is aluminum, except this one's hollow, and it has a little bit of duct tape mess on it, and then this is just a solid piece of aluminum rod, so we have that going for us. And then next to the aluminum, we have some stoppers, so things that we would cork a flask with or a test tube with or something like that. So this is made of cork, right? So we have a cork stopper, and then we have a rubber stopper. And what I want you guys to do is order these things from what you think is the least dense to the most dense. Okay, so order these from least dense to most dense. Okay, so I can't really, since we're not live, I can't see exactly what your answers are, but I could go off of what I've seen in previous years and just what our normal intuition kind of tells us. Most people, I would think, are kind of bouncing back and forth between these two. Right? We're trying to figure out. Most people think that one of these two is the least dense. Now, me, I can kind of pick them up and hold them, and so the aluminum can feels a little bit lighter to me. So maybe that one is less dense than the cork. So I might put this one first in terms of its density, and then maybe I'll put the rubber stopper or the cork stopper next. Then it gets into these guys here, aluminum versus the rubber. And once again, if you're sort of holding them and measuring them, like this thing is pretty big, it's pretty thick, right? It's not, it bounces a little bit. It's pretty solid. And this guy here is the same. So, this one once again is a tough one. I would say that maybe, I don't know, maybe this, and then maybe this. I don't know. You guys might flip them. You might go this way, but I would say that most people would say that the bowling ball is going to go ahead and come last on that in terms of density. So, when we're talking about density, what is it that we're looking for? What helps us determine if something is dense or not? Well, most people say, if it's really heavy, it's weight. If it has a lot of weight, it's probably dense. Okay, so that makes sense, right? This thing, I would say, is probably not very dense, and this thing is more dense than that. This one's heavier. Okay, so how do we test this? How do we see if we got this right? Okay, well, most of the time you can compare density. What we find is that things that are more dense tend to sink, and things that are less dense tend to float. That's the whole idea behind a boat, right? So let's throw some of these things in water and see where we land. See if we kind of come up with the right answer here. So we're going to go ahead and grab this, and we're going to start putting some stuff in here. Okay, now it might not be a perfect comparison, but if they both float, we see which one floats better. If they both sink, maybe which one sinks faster. So if I put the can in the water and I put the cork in the water, which one is more dense? So let me kind of come around here and look and see which one is more dense if we're looking at that. So like if I could zoom in a little bit, it almost looks to me like the cork is sitting farther down in the liquid than the soda can is. So I think we might have had that one right. Looks like the can is definitely hanging out higher in the liquid than the cork is. So I like that. I think that we've got that right. So we'll pull this one out and this one out. I think that that order is correct. Next we would have these two to kind of compare. And so I would guess that neither one of these is going to float. So we'll put them both in the water at the same time. Odds are they're going to sink, and maybe we can see which one sinks faster. Now there's going to be a little bit of uncertainty here even in that test because the surface area, right, the amount of resistance that it's going to have, like this is much wider. So as it tries to sink, it's having to push a lot more water out of the way than something like this. But we could go ahead and see if I count 1, 2, 3. Looks like the aluminum went down really, really fast. Now, like I say, it could be a surface area thing, but you know, maybe the aluminum is just more dense. So I'm gonna go ahead and for the purposes of this, I'm gonna flip my answer. I'm gonna go ahead and put the rubber stopper next, and I guess metal. I mean, it is metal. Metal is usually pretty dense. And then the last one we have would be the bowling ball. Now, I don't really want to just like drop this in here and shatter the bottom of this tube, but I will put it in. So we'll go ahead and we'll set this in gently. Looks like it can go. And then I'm going to let it go. Well, that's weird, right? So people are like, what the heck? Why is that happening? Look, you can see it's moving. It's not like it got stuck. It's not like it's wedged in there. The bowling ball is the heaviest thing here, but it's less dense than both of these, right? Than the rubber and the metal. The bowling ball is kind of crazy. It's big and it's heavy, but it's floating. So it's actually not that dense if it's floating like this. So density is not just weight, right? There's something else that's going on that we need to take a look at when we're talking about things like density. So let's go ahead. I'm going to go ahead and get this out of the water here before something happens. But let's go ahead and that's the little finger holes there that were holding some water for me. We're going to go ahead and flip over to Notability, and we're going to take a look. What exactly is density? Dry my hands off here. Now, when we're talking about density, we were just discussing this concept that the less dense item typically goes up to the top, right? And so what's going on here? Well, density is all about how things are packed. We say that density is an intensive property. It's really only dependent on the composition of the substance, not the size. So the bowling ball was really big, the bowling ball was really heavy, but that's not what matters. It's how the particles are packed inside of there. It's not just weight. You can have 1,000 pounds of feathers and you can have 1,000 pounds of nails, right? They both weigh the exact same thing, but the density is going to be very, very different. So what we're looking at for density is it's actually a relationship. It's a comparison. It's not just the mass, but it's also the space that it takes up. So it's mass divided by the volume, right? So if we look at that aluminum rod that I had out, and we look at that aluminum can, the aluminum can and the aluminum rod weigh roughly the same thing. They were both about 10 grams. But this one floated and this one sank. The reason is because of the space that they take up, right? So we say the mass divided by the volume, and remember that volume, a centimeter cubed, is the same thing as a milliliter. That's interchangeable. So we would say that the mass divided by the volume is going to give me my density. Mass divided by volume is density. Same thing over here. And so now look, the density of that aluminum rod is much higher than that of the aluminum can. And this floated. We know this is a fact, right? If you walk over and you stomp on the aluminum can, my volume decreases and my density goes up exponentially, right? It's going to jump up really, really, really high. Now, this isn't just true of solids. This is also true of gases. So if we look back at this table here, I've highlighted 3 different gases. Things that we find in our daily lives. Carbon dioxide is what we're breathing out. Oxygen is what we're breathing in. And methane is basically what we would use in our Bunsen burners in class, or maybe your stove at home if you don't have an electric stove, if it's a gas stove. Methane is the gas that's in there. So let's take a look at these. If I was to take carbon dioxide, oxygen, and methane and mix all of these gases together in one container, what would rise to the top? Right. So if we're looking to see what would rise to the top, we should expect to see the less dense item, the least. So 0.66 is the least dense out of all 3. This should go to the top. This should go in the middle, and this should go to the bottom. Well, we can test this, just like we tested with the water. So let's flip back over here to the camera again, and we're going to sort of zoom in a little bit here. And this time, I'm going to move this out of the way here. So let's move this. And we're going to bring in a new container. We're going to go ahead and bring in this fish tank. All right, so we've got the fish tank here. And what we're going to do is we are going to mix some gases in this fish tank. So I'm just trying to get it centered on the camera so you can actually see what's happening here. All right, so we've got it centered on the camera. And what we're going to do is we're going to mix some chemicals. The first chemical that I'm going to put in here is sodium carbonate. So let me put some goggles on. Anytime we're working with chemicals in the class, we want to make sure that we're wearing goggles. So we put the goggles on. I'm going to go ahead and start dumping some sodium carbonate into this. Okay. So I'm just getting a lot of sodium carbonate in here. Hopefully that's good enough, so we'll set that there. The next thing that I'm going to do is I'm going to dump some hydrochloric acid into this. So we have the sodium carbonate and we have the hydrochloric acid. And basically what this is going to do is we're going to see some chemistry now. We're going to see a chemical reaction. So maybe I could fit this on the board. We have Na2CO3 is going to react with the HCl. This is a chemical equation we have. And what's going to happen is these things are going to go through a chemical change, right? Their natures are going to change. And it is going to break down. And we're going to get salt. We're going to get water. And we're going to get CO2. That's the gas that's on our list there. We are saying that it should be one of the most dense gases of that list. So we're hoping that that should be the gas that's at the bottom. So let's go ahead and start dumping some of this in. I'm just trying to get the ACs on right now, and I'm afraid it'll blow the gas right out of here. So I'm going to try and... So as I dump this in, you guys should see lots of fizzing in there. So I'm just going to kind of let it keep swirling around. Maybe a little bit more. Okay, now what we're going to do is we're going to introduce oxygen to this. And the way that we're going to introduce some oxygen is with some bubbles. What we're going to do is I'm just going to blow some bubbles. And the idea is that, yes, there will be a little bit of carbon dioxide in there. Geez, you need like a PhD to get this thing out of here. Dang. There we go. I'm going to blow some bubbles. There's going to be a little bit of carbon dioxide in there, but there is going to be a lot of oxygen because I'm not going to blow from deep in my lungs. I'm going to blow mostly out of my mouth which hopefully will be mostly oxygen. So we're going to pull this off. Ah! I went in too hard. Oh, what's going on here? Need some more. Get some more carbon dioxide going. There we go. Can you guys see that all right? What's that bubble doing? It's the infinite floating bubble. Why is the bubble floating there? Because we generated a ton of carbon dioxide gas, which is more dense than the gas that we see inside the bubble. So we can see, get some more floating there. Right? Lots of bubbles floating around, right? They're not sinking like they normally would without that other gas present. Okay. All right, so the last gas was methane. We expected the methane to go up to the top. Now I can't necessarily get the methane into the aquarium because it's lighter than all the other gases. It's going to want to leave the aquarium. It's going to be very difficult to see. So I'm going to go with the bubbles again, but this time instead of blowing the bubbles with my oxygen that's in my mouth, I'm going to go ahead and use the methane out of the gas jets. So to do that, I went ahead and I just put a funnel on to my hose here, and I'm just going to basically use the funnel to create those bubbles. So if this is lighter than oxygen, which is a lot of oxygen in this room, we should see the bubbles going up here. So we're going to go ahead and turn the gas on, and we start to blow our bubble here. There it goes. Yeah, so we see our bubbles, they're going up. And we can prove once again that these things are methane. We can prove that they're methane by putting a little bit of flame to it. So we're going to go ahead and blow some bubble here. We're going to do this again. We can see that it's lighter than air. And it's very flammable, right? That methane is good stuff. Okay, got a little bubble there. Maybe one more. All right. Oh, we still got one more. Got to go until we're out of methane, right? Oh, there it went. Okay, so we can see that the methane is definitely less dense than the oxygen, right? It went up. The oxygen, the bubble floated right in the middle, and then below that was the carbon dioxide. All right, so we now know, I think in the video I might have said lighter than air a couple of times. It's definitely lighter than air, but it's less dense is the key. Basically, we would say they were separate, the distance between the atoms in methane was greater than the distance between the atoms in things like carbon dioxide. So our densities that we see here are holding up nicely. Now there is a way for us to change the density of a substance, right? We know that like with the aluminum can, I could stomp on it and I could smash it down. Well, what about something like that gas? Like what about air? What if I wanted air to become less dense than it normally is? What could I do? Well, we know the density is basically looking at how much space it occupies. Well, one thing that we find is that if you heat something up, the particles move faster and they spread out. And we've all seen hot air balloons before, right? The idea is that we're adding heat to our air, causing them to move faster and spread further apart than they normally would be. So their mass is staying the same, but they're spreading out and taking up more space. So they become less dense, kind of like stretching an aluminum rod out into a can. There's only one exception to this, and I have that down below there. Water is an exception. Water is a strange chemical. It's very unique in that it actually changes. So if you have water as a liquid and you start heating it up. So say it's like water at room temperature, like 20 degrees. You start heating it up, it will become less dense. And it'll eventually turn to a gas. And that gas, if you heat that gas up, it will become less dense and less dense and less dense. But there's a weird phenomenon, and that is water as a liquid. When you cool it down, it should become more dense. So if you started at water at room temperature, you start cooling it down, cooling it down, cooling it down. When it turns into a solid, it actually becomes less dense, right? That's why ice floats. It's really, really weird. Water's just a strange chemical, and we're actually going to spend a lot of time in the future talking about how weird water is, which is actually very important to our survival on this planet. But let's go ahead and wrap up here. So now what I have is a little chart here, and I would like you guys to try and figure out what these different densities might be. So if I'm missing something here, I'm looking for a density. Here I'm looking for grams. Here I'm looking for volume, and here I'm looking for grams. So let's start. Number 1, Karo syrup. If you have a volume of 30 milliliters and a mass of 41.1 milliliters, what would the density be? Number 2, 15 milliliters of water, 15 grams of water, what would the density be? Number 3, if you had 25 milliliters of alcohol, rubbing alcohol, and you knew the density was 0.87, what would the mass of this be? And then vegetable oil, what would the volume be? And the dish soap, what would its mass be? All right, so now what we're going to do is go ahead and test that. Did we get our densities correct? Now, these different materials, just because they're not gas or float in water, we still should be able to see them layer out with the most dense item at the bottom, the least dense item up on top. So the Karo syrup, for those of you who don't know what that is, that's like, it's a thick syrup that often is used on like pecan pie and stuff like that. I'm not a fan of it. I don't really like the taste of it, but it is, you can see it is thick stuff. Very, very thick, very viscous is the scientific term we would use. This is what we should have calculated as being the most dense. Next, we should have had the dish soap. So I've got the Dawn dish soap here. And then we have water. Now, water is clear. It's a little hard to see, so I'm going to go ahead and put a drop or 2 of red food coloring in it. And so we can go ahead and put some red food coloring in there. Next, we should have the oil, the vegetable oil, and then finally the rubbing alcohol. So we're going to go ahead and start with the Karos. And if we put this stuff in here, if I'm careful, I shouldn't slop it down the side too badly. We can see that it's nice and thick. Okay, 1 second here. Nice and thick. Sorry about that, guys. Somebody needed something from me. So we're going to go ahead and add, we've got the Karo syrup in there. So we've got a little bit of Karo syrup. That's at the bottom. We're going to go ahead and put the dish soap in next, which is nice because it helps clean this whole mess up. Go ahead and put a nice layer of dish soap in there so that we can see it. And so we've got the Karo syrup at the bottom. We have the dish soap sitting on top. Now the water is pretty amazing to me because you mix water and soap to get all this to clean up. But if you're gentle with how you put it in, if you're nice and gentle, even though it starts to mix, the water goes right back up on top of the soap. So you just have to give it a second. And you see that it started trying to mix, and then all of a sudden the water just rises to the top. So it would take me like reaching down in there with like a glass stir rod and stirring it up to get all that to mix. If If I put the oil in next, I should have the oil sitting right on top. Brand new oil here. Go ahead and pour a little bit of that. There we go. So our oil is layered up on top there. And then finally we should have the least dense of them all, the rubbing alcohol. So let's go ahead and pour a little bit of rubbing alcohol in here. See, it's trying to mix because I'm pouring it like a caveman, but we can see that it went all the way down and touched the water. It grabbed a little bit of pink, but then it separated right back out again. So we see our alcohol, our oil, our water, our dish soap, and at the very bottom there, we have our Karo syrup. We can probably do a little better of letting you guys see this here. So let's bring it a little bit closer. So we've got the Karo syrup at the bottom. We've got the soap, the water, the oil, and then right up on top there. And it's actually, you can try and swirl it, you can shake it a little bit. I mean, it doesn't do it very much in terms of mixing. It shakes around a bit, but it doesn't do much because those densities are so different.